Hello students, in part 1 of electricity we try to understand what was charge, electric potential and electric current. So a quick recap, what is potential difference? So it is work done to move a charge from one point to another inside a electric field. And what is current? Current was the movement of charge, or you can say the flow of charge. Let us discuss the same example that we took in understanding the concept of potential difference. So we are seeing tank A and tank B and tank A has water at higher potential as compared to that of B, and the water was flowing from tank A to tank B because of the potential difference. So what if we are increasing the level of water in tank? So the potential on tank A will increase and simultaneously the flow of water will increase, or you can say the water flow through the pipe connecting tank A and tank B increases because of the increased potential difference. Similarly, if we are taking a conductor and that conductor we are connecting through some cell to make a potential difference or a battery. So if we are taking a smaller battery, so the potential difference is less and the rate of flow of charge is less through the conductor. And if we are increasing the batteries, then what will happen? The potential difference will increase and simultaneously the flow of charge increases. So we can understand that with increasing the voltage or potential difference, the current through the conductor is getting increased, and this type of relation is direct relation, which is nothing but the Ohm's law. So if we have to define Ohm's law, what is Ohm's law? So at constant physical conditions, so we are talking about physical conditions like temperature and pressure. So whenever we talk about Ohm's law, we take certain temperature, and at that temperature only we talk about the relation between voltage and current. So at constant physical condition like temperature and pressure, the current flowing through the conductor is directly proportional to the potential difference across its end. So we understand that it is V is directly proportional to I, or you can say I is directly proportional to V. So if we increase the voltage, the current increases, and if we remove the proportionality sign, a constant is introduced, and this constant here is R, and R is resistance. So if we talk about the graph of Ohm's law, then V is directly proportional to I, or you can write that V upon I is constant. Such type of relation gives us a linear graph, that is a straight line. So whenever we talk about linear graph in mathematics, you would study that linear graphs are straight lines. So VI graph is always a straight line, and on this graph we have two types of devices. One is ohmic device, or you can say linear device. The device is like resistance that follows the Ohm's law, and there are certain electronic devices that does not follow Ohm's law, and such devices are called as non-ohmic device or non-linear device. These ohmic device and non-ohmic device is just for your extra knowledge. We will study only about resistance. So next comes is what is resistance. Before going to resistance, let us see on what factors the current depends. So from Ohm's law, we got to understand that current depends on voltage, and if voltage is increased, the current is increased. But from the same relation we can write I is equal to V upon R. So there is one more factor that is affecting the current, and that is resistance. So we can find that I is inversely proportional to resistance. So if R increases, I decreases, or if R decreases, then I increases. So we have an idea, and we have seen how we express or what is the symbol of resistance in earlier class. So I told you that it is nothing but a hindrance in the path of current. So if we have to define resistance, it is the property of a conductor due to which it opposes the flow of current through it. And from Ohm's law we can get a formula, that is R is equal to V upon I, and the resistance SI unit is ohm, and the symbol of ohm is given in the bracket. So there are certain factors onto which the resistance depend, and the factors are length, thickness, nature and material, along with temperature of the conductor. So the factors that are affecting the resistance of conductor is first length. So length directly proportional. Resistance is directly proportional to length, means resistance increases with increase in length, and the resistance of a conductor is inversely proportional to the cross section area. So if resistance increases, then that means that cross section area is decreasing, or you can say a thick wire will offer lesser resistance and a thin wire, or the wire with lesser cross section area, will offer higher resistance. For example, suppose there are two pipes. One pipe is with lower cross section area and one pipe is with larger cross section area. If same amount of water is to be flown through both the pipes, what will happen? In the pipe with lower cross section area, the pressure inside the water will increase, whereas in the pipe with higher cross section area, the pressure will be decreased, or you can say the flow of water there is decreased. Similarly, if the cross section area is decreased, then the resistance offered by that material is getting increased. So let us take an example. If we talk about length, if the length of conductor is doubled, then obviously the resistance is going to be doubled, and if the length is halved, the resistance is going to be halved. Similarly, in case of area cross section, if the area is doubled, then what will happen? The resistance become 1 by 2 times, or you can say it is halved. Now if area is halved, the resistance become 2 times. When we will solve numerical, we will be able to understand how it is happening. So the other factors onto which the resistance depends is the nature of material and temperature. Now, as we studied Ohm's law, we said that under constant physical condition, and there we saw temperature. So here you will understand that with the temperature increase, we observe that the resistance of pure metal increases. This happens due to the vigorous movement of electrons on getting heated up. And in some alloys like nichrome and manganese, there is no effect of temperature. But since we take most of the metals, so the temperature, with increase in temperature, the resistance is increasing. So we always talk about a constant physical condition, and at that constant physical condition, the V is directly proportional to I, or you can say that Ohm's law is followed. If we go on with the same formula where R is directly proportional to L and R is inversely proportional to A, so we can write R is directly proportional to L and inversely proportional to A, or you can say R is proportional to L upon A. And when we remove the proportionality sign, again a constant is introduced, and here this constant is rho, and this rho here stands for specific resistance or resistivity. Specific, this word itself tells you that the resistance of a specific material, so it is material dependent. So if someone asks how to define resistivity, so we can just write by the formula R is equal to rho L upon A. If we transfer the values, we get rho is equal to R A upon L, and if we take the cross section area as 1 meter square and length as 1 meter, we know that in SI terms we take meter as length, so we get rho is equal to R, and then the definition becomes very easy, that resistivity or specific resistance is a resistance offered by a material of unit length and unit cross section area, or you can define it in one more way, that specific resistance is the resistance offered by a unit cube of a material. Unit cube. Why unit cube? Because if we find the volume, then unit length into unit area will become a unit cube of volume, and the unit for this becomes ohm meter. Here you can see that resistance is ohm, area is meter square, and length is meter. So meter square get cancelled out, and it remaining is ohm meter. So this resistivity is depending on the nature of material and temperature. Just for your extra knowledge, that there is one more term that is called as conductance, and this conductance is opposite of resistance. This is not part of your syllabus, but for your extra knowledge, that conductance is represented by G, and you can say it is the degree of easiness with which the current flows through a material, and the SI unit is महो. OHM ओम होता है and उसको उल्टा कर दो तो MHO महो, or you can write it as Siemens. This is for your knowledge. So you can get a brief idea that with the resistance, you can say that if higher the resistance, then the material will be bad conductor, and lesser the resistance, then material will be good conductor. Here are few questions that you can practice at home, and in next class we'll try to solve the numericals based on the formulas that we studied today, that is V is equal to IR and R is equal to rho L upon A. These two topics are very important for exam point of view as well. So in next class we'll only practice numericals before proceeding to the circuits of series and parallel combination. I want you to attempt these very easy questions based on lecture 1 and lecture 2, and in next class we'll study numericals. Till then, thank you